Hello, this is Shadi and Tianlun reporting our results for finite element analysis of heat transfer in fins. Fins are modeled to determine length to ensure optimal operation of heat generation. The rate of heat transfer was studied for two fin geometries, including rectangular and cylindrical pin fins. We verified the ANSYS accuracy with equations used in heat transfer for infinite fin length, and we utilized the design parameters and material properties for copper and aluminum fins. So we calculated the heat transfer for fins of an infinite length and then calculated the heat flux in order to compare it to our ANSYS results. The cylindrical pin fin was the most efficient for heat transfer in both cases. The theoretical analysis for the heat flux and heat transfer are all larger than the ANSYS calculated results due to discrepancies in the fin lengths used, and we will discuss this later. The equations that we used for heat flux and heat transfer are shown below. We utilized ANSYS for the FEA. We first inputted the isotropic thermal conductivity, then added the element type, then modeled the fin, then meshed the fin. We then defined the thermal load, including a temperature load at its base and a convection load along the length of the fin. We then solved the problem and plotted our contour plots.
Our results evaluate heat flux values by calculating theoretical heat transfer and dividing by the corresponding surface area for the given geometry. Our result and the plot are shown below.
We found that copper is more efficient than aluminum due to its higher thermal conductivity, and that a cylindrical pin fin is more efficient than a rectangular fin due to its higher heat transfer and optimal temperature distribution. The discrepancies that occurred between theoretical analysis and ANSYS analysis was due to the length used in ANSYS of 10 centimeters, which was found through iterations. Rather, the theoretical analysis length of 35 centimeters should have been used to approximate infinite length. Due to this discrepancy, the ANSYS heat transfer results are smaller than the theoretical analysis heat transfer results. However, the results would be similar if direct lengths were used in ANSYS, thus proving accuracy between ANSYS calculations and the theoretical analysis. The results still do prove that cylindrical pin fins are more efficient than the rectangular fins.
Thank you, and any questions?